Hello everyone, can you hear me? Hi guys, good evening. What we will cover today is we will see a very important topic. It is ILRs, and as you all suggested me, I will go slow today. Okay, we will start ILRs. We will see what is remainder because we have already seen it, and we will see the ILRs application. We will also see a factorial application. These two things we will see today. And today it's going to be a shorter class. So stay tuned. Meanwhile, just inform everyone that the class has begun so that we can start ASAP. Any doubts in number system so far? Anyone? Any doubts so far in number system? If this is interesting for you, then I can assure you that in the coming future, it's going to be more interesting. Today, we will discuss Eilers, and then we will discuss Wilson theorem, Fermat theorem, CRT. Numbers is one very interesting topic. And I hope you guys are giving mocks. That is very important, everyone. Please start giving mocks. 19 into 50 mod 101. Can we find this without calculating? Anyone? Can we find this without? I've not started those who have joined just now. I haven't started the class as of now. I'm just waiting for you guys. Quickly join so that we can start. Okay, everyone, just quickly join so that we can start. Yeah. So yes, Saeed has asked this question. Can we do something to this to make it an easy calculation? Everyone try it out. Tell me, how can we make this an easy calculation? Guys, I haven't started the class as of now. I'm just taking a doubt. So we'll wait for 1 to 2 minutes and then we'll start the class. Everyone, please try this out. I have to find this mod 101. Any easy way to do it? Quickly. Any easy way that you can think of how to calculate this? It's basically 950 minus 909. Okay, fine. Yeah, that is fine. But you asked me that if I do not want to calculate this, right? That's what you are asking, Said. I do not want to get this 950. Then how can I do it? So there is a method, or see, it's a very basic method. This is what mod 101, right? I can make this 100 or close to 100, right, Said? I can write it as something. I can write it as close to 100. That is 15 to 20 minus 50. Can I write it like this, Said? I can write it like this, right, Said? Yes. What is 15 to 2, Said? 100. What is 100 mod 101? What will be 100 mod 101? Minus 1. Exactly, Said. Yeah. Now you got it. How can we do it so easily? This will be minus 1, right? Into 10 is there. And then again there is a minus 50. So that then you can calculate it easily without getting this 950, right? We'll get the same answer. This is how you can make it easily. No, Priyam, it will be from 8:30 or it will start from 9. These are the two timings. Okay. Whether it can be 8:30 or it can be 9. Chalo, we have few participants now, and then we can start today's class. Let's start. And guys, just an announcement as in that today's lecture will be a shorter one. Okay. And I will also cover just 2 topics. I'll try to cover 2 topics only because in the last class some of you said that it was going pretty fast. That is why I've decided that I will take more number of classes for it, but it will be a shorter one. This class will be a shorter one, and the concept of Eilers will be discussed, and factorial maybe. So let's start this class now. Yes. So first question for today is, what is the remainder when 9 to the power 24 is divided by 79? Right now, I am unaware of Euler. There is nothing called Euler's theorem. Do this question by simple method. What is the remainder when 9 to the power 24? Or I'm asking 9 to the power 24 mod 79. Calculate it by simple method, simplest of the methods. Okay, let's see now. See, what is the simplest way to do it? Right now, I'm unaware of anything called as Euler's theorem. Okay, 2 to the power 12, Rahul says. Okay, let's see, Rahul. This is first of all 3, right, Rahul? So how this is 2 to the power 12? Okay, we'll see how to solve it. Just have a look. This is 9 to the power 24, right? Yeah, 81 to the power 12. Yeah, then it can be. Yes, exactly. Yeah, then it is fine. I said that you are saying that this will become to the power 12. That is what we will do. What is 9 square? 81, right? what I have here is 79. So my objective is to get this number as close as 79, right? What is the closest I can get? 81. So 9 square is 81. This to the power 12 mod 79. Fine. 9 square is 81. So what is 81 mod 79? That is 2. So this becomes 2 to the power 12 mod 79. How to solve it? Again, I want to get as close as possible. Now, how can I get, tell me which power of 2 is closest to 79? Quickly. Which power of 2 is closest to 79? Yeah, exactly. So this will be 2 to the power 6 into 2 to the power 6 mod 79. What is 2 to the power 6? 64. What is 64 mod 79? Minus 15. This will be minus 15 into minus 15 mod 79, right? Which is nothing but 225 mod 79. Now this becomes really simple. Okay. Now what is your answer? 67. Clear, everyone? How we got this? Any doubts? Anyone? This is without any theorem, without knowing anything, just by simple remainder concept. How can we do it? This is applying simple remainder concept. Okay. Any doubt in this one? Anyone? Raghu, I told that this is the simplest remainder concept. If I am not knowing Euler's theorem, if I am not knowing any theorem, okay. Pranjal, you are not clear, there is no doubt. So if you are not knowing any theorem, then how can you solve this question? So the objective will be to getting close to this number, as close as I can get, okay. The closest that I can get to 79 is 81, right, Raghu? So yeah, so this will be 81. So what is 81 mod 79? This becomes what? 81 to the power 12 mod 79. What is 81 mod 79? 2. This goes to the power 12 mod 79. Again, how much close can I get to 79? Which is to the power 6, which is 64. So this becomes minus 15 into minus 15 mod 79, which is 225 mod 79. Your answer is 67. Okay. Now let's move forward. Solve this question. Right now, no theorems. Don't use any theorems as of now. That will be covered later. Just use basic understanding. See, what is this? Mod 66. What is 66? 6 into 11, right? So after 11 factorial, everything will be 0. This whole thing will be 0. Why? Because 12 factorial is what? 1 into 2 into 2 into 3 into 4 till 12. This covers this 6 and this covers this 11. Right, guys? So this all will be 0. This all will be 0. Okay. What am I left with? 3 factorial, which is 6, plus 6 factorial, which is 720 mod 66. The simple question becomes 726 mod 66. Again, you can see this is divisible. Apply the divisibility rule. Divisible by 6, yes. Divisible by 2 and 3. Divisible by 11, yes. Why? Plus minus plus. What is this? 11. And this is divisible by 11. Hence, this is divisible by 66. Remainder is 0. Understood? Any doubts in this one? Most of you solved correctly. So, any doubt in this one? No? Fine. Next question. Find the last 2 digits of this. First of all, how to find the last 2 digits? If I'm saying last 2 digits, then it is mod what? Suppose if you want to calculate the last digit of this number, what you will do? You will divide this number by 10. Why? Because if you will divide this number by 10, 10 divided 3254 divided by 10, this is 325, this is 3250. What is the remainder? 4. So the remainder is the last digit. If you divide this number by 100, then what will be the last digit? This will be how much? 32. 3200. This will be 54. You will get the last 2 digits. For getting the last 3 digit, you will divide it by 1000 and so on. Right, guys? So here what I'm asking, last 2 digits. So this has to be divided by 100. Or the question says, find this mod 100. This is what the question is saying. Find this mod 100. Ishan says 3, Rahul says 13. Okay, others? See, what is this? This mod 100, right? So after 10 factorial, suppose if I'm taking 11 factorial, because 100 is what? 100 is what? If I'm doing the prime factorization, that this is basically 10 into 10, right? So this is 2 square into 5 square. Okay. In after 10 factorial, what is happening? I'm getting a 2 here. Yes, I'm getting a 2 here. Am I getting a 5 here? Yes, I'm getting a 5 here. And another 5 into 2, I'm getting in 10 factorial, right? Into 10, I mean. So after 11 factorial, everything will be 0. Is this clear, everyone? That after 11 factorial, everything will be 0, right? Everything will be divisible by 100. So we have to calculate till 10 factorial only, till 10 factorial only, right? And that too we are concerned with last 2 digits only. Okay, so what is 1 factorial 1, 2 factorial 2, 6, 24, 120, 720. Till here it is fine. After here, you do not want to calculate everything because we are concerned with last 2 digits only. What is this into 7? What was the last 2 digits? 40. What is this into 8? What is the last 2 digits? 20. What is this into 9? What was the last 2 digits? 80. I don't care what is there in this portion. Okay. I just want to calculate the last 2 digits. Now what we have to do? What we will only consider 20 from here. We will only consider 20 from here. We will take it as 30. It has 3. This calculation is really simple. 80 plus 20, 100 again cancelled. 40 plus 20, 60 plus 20, 80, 110 plus 3, 113. Answer is 13. Clear, everyone? Any doubts in this question? Okay, 11 factorial wala once more. ठीक है. See, what is this? I want to calculate. Let me erase this. I want to calculate 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5. Yeah, we will take till 9 factorial only. We will not take 10 factorial even. Even if we are taking, answer won't matter because we have taken a divisible number, but we will take till 9 factorial only. Okay, Mukul? So what is 10 factorial? 10 factorial is 1 into 2 into 3 into 4 till 10, right? We have to divide this number by 100, right? So place per maybe carry. No issues. No issues will be there if we will take that also. Why did we take the last 2 digits? We are taking the last 2 digits because the question says find the last 2 digits. Suppose now Priyam, tell me if a number is 2323. Okay, if I'm adding 2323 to 1267, suppose Priyam, right? I am writing this mod 100. So I can write it as this mod 100 plus this mod 100. This mod 100 will be 23. This mod 100 will be 67. Again this mod 100 I can write, right Priyam? It can be written. I can just divide this mod into these two and then I can write it. So that's what I am doing. That's why I am taking the last 2 digits only. Okay, clear Priyam? Now Gayatri, regarding this issue, this is 1 into 2 into 3 till 10 upon 100. So in 100 what am I having? I am having 2 5s and 2 2s. Okay, 1 5 I will get from here into 5. 1 5 this will give me. When will other 5 come? When it will reach 10, then only other 5 will come, right? So I will get 5 square once it has reached 10. Hence, post 10 factorial, I don't need to consider anything. Everything will be 0. Now is it clear to everyone? Now is it clear? We have done Priyam. In the last question also we did. We took it as 81 in what we took? 81 into something, right? Into 10 something we took, right? In the last to last question. There also we divided. So next question. Not question basically, but we will discuss Euler's theorem now. So what is Euler's theorem? Euler's theorem is there to make your calculation part easy. Okay. Suppose there is a number, let's say 100. Okay. Now, if I want to divide this number 100, how will it be divided into prime numbers? 100 will be divided as 2 square into 5 square, right? If I want to calculate the Euler of n, first of all, I'll tell you the formula to calculate the Euler of n. Then I will tell you what is the concept of Euler of n or what is Euler of n. So I will take 100. I will multiply this number by 1 upon 1 minus this number, is 2. Okay, that's what I have written. Euler of n is n into 1 minus 1 by a into 1 minus 1 upon this number, which is 5. Okay, so you will get the Euler of n as 40. Clear? What is Euler signifying? Euler is signifying that there are 40 numbers that are That is the number of co-primes. Yes, that's what I'm saying. That there are 40 numbers which are less than 100 and are co-prime to 100. Okay. Euler signifies that how many numbers are there which are less than 100 and which are co-prime to 100. Okay, everyone. This is the simple formula to calculate Euler of any number. Fine. Now, what will be the Euler of a prime number? Suppose if I'm having a prime number 7, how many co-prime numbers will be? Every number will be a co-prime number, right? Because this is a prime number. So every number below this number will be a co-prime number. That is why Euler of a prime number is always p minus 1. Using this formula, Euler of a number is 7 into 1 minus 1 by 7, which is nothing but 6. Okay, guys, this is what Euler signifies. This is what is the formula for Euler. Now, how to use it in questions? How to use this Euler concept in question? Application. Application is to find the remainder if power is too large. We solved the question just now. Yes, Rahul, interesting question. Is 1 co-prime to all? Is 1 co-prime to all? Because if I'm saying 7 is having 6 co-prime numbers, which is 1, 2, 3, 4, 5, 6, I am taking 1 as well. But is 1 co-prime to all? If yes, then why? Everyone, why is 1 co-prime to all? Yes, 1 is co-prime to all. Okay. What is the definition of co-prime numbers? What is the definition of co-prime numbers? Common factor is 1. Okay, then if I'm taking 1 and 7, then 7 is also 1 into 7, right? So common factor is 1, right? If I'm taking 1 into 7, then what is the common factor? Common factor is 1, right? And the co-prime number says that the common factor of these two numbers should be 1, or that you correctly mentioned, GCD or SCF should be equal to 1, right? Hence 1 is co-prime to each and every number, right? Now Priyam is asking example of those 40 numbers. Now I will not list those 40 numbers, but look here, Priyam. 100 is having what? 2 square into 5 square, right? So what all numbers will be there? 1 will be there, 3 will be there, Priyam, 4 won't be there, 5 won't be there. Will 6 be there, Priyam? Now you tell me, will 6 be there? Quickly, Priyam. No, obviously 7 will be there, 8 will not be there, 9 will be there, and so on. Clear? In this way, we will get 40 numbers. Anyways, so how to apply? What is the point of learning this theorem? Which is the application part. So if I am seeking 3 to the power 104 mod 7, then what this will be? To apply Euler's theorem, okay, see, in the last example, 100 is what? 2 square into 5 square. Why 6 is not co-prime to this? What is the common factor between 6 and 100? 2 is common, right? This is 2 into 3. And this one, hence they both won't be co-prime, obviously. Yeah. So if you are solving this question, so what is the condition to apply this Euler's theorem? It is used to when the remainder is too large. Okay. Only condition that you will keep in mind is that these both numbers must be co-prime to each other. Okay. Only keep this condition in mind and apply the Euler's theorem. So how you will apply the Euler's theorem? You will take out the Euler of this number, which is 7. Now what is the Euler of 7? It will be 6. Why? Because this is a prime number. Hence Euler will be 6. So I will say, which means if Euler is 6, 3 to the power 6 mod 7 equal to 1. This is what Euler theorem says. That if we are seeking 3 to the power 104 mod 7, why this is coming? This is not needed. If you want me to explain, I can, but this is actually not needed. Why? Because this again deals with concept of co-primes and all, which is not needed as far as CAT is concerned. Okay. What Euler says, if these two are co-prime and there is if just Euler of 7 is 6, then 3 to the power 6 mod 7 will be equal to 1. This is what Euler says. Okay. I hope till here it is clear. This is a simple theorem which says take out Euler of this number, take out Euler of 7. Okay, Euler of 7 is 6. What do you have to do? 3 raised to the power 6 mod 7 equal to 1 if these two are co-prime to each other. Fine. Now if 3 to the power 6 mod 7 is 1, I can write 3 to the power 12 mod 7 is also 1. I can write 3 to the power 18 mod 7 is also 1, right guys? So what I need to do, I need to come closest to this 104. Okay, I need to come closest to this 104. What is the number which is closest to 104, which is divisible of 6? See, Priyam, what is the Euler of 7? Euler of 7 is 6, right, Priyam? So this is Euler's theorem, which says that if these two numbers are co-prime to each other, then take out the Euler of this number, and simply you can do 3 to the power 6 mod 7 equal to 1, right? And why 6? Why 6? Because Euler is 7 into 1 minus 1 by 7. Why this? I just now told you. Factorize it. What is the factorization? 7 into 1 and 7 into 1 minus 1 by 7. Or you can also say that 7 is a prime number, hence this will be p minus 1. Yeah, that I'm coming to. Wait. That I'm coming to. Don't worry. Till here, is it clear? Till here, is it clear? Everyone? That then what? Because 3 to the power 6 mod 7 will be 1. 3 to the power 12 mod 7 will be 1. 3 to the power 18 mod 7 will be 1. Right? Then 3 to the power 102 mod 7 will also be 1. Right? 3 to the power 102 mod 7 will be 1. I'm getting nearest to this 104. What is remaining? 3 square is remaining. 3 square mod 7 is my answer. What is 3 square mod 7? 2. My answer is 2. 2 is the remainder when 3 to the power 104 is divided by 7. Okay. Let me just explain it quickly once more because you guys are getting confused. Question was, find out 3 to the power 104 mod 7. Okay, this was the question. Now there is a theorem known as Euler's theorem, which says that if these two numbers are co-prime to each other, if 3 and 7 are co-prime to each other, then this is the theorem. Theorem is saying this: 3 to the power Euler of this number. What is Euler of 7? 6. Mod 7 will be equal to 1. The reason, as I mentioned, that reason comes from co-prime numbers application, but this is not needed as per CAT is concerned. Trust me, this is not needed as per CAT is concerned. If I will go into explaining, then it will take time also, and you might get confused also. That is why I'm not explaining. Where explanation is needed, I always give you explanation. Okay. Simply, you have to learn this as a theorem that if these two are co-prime to each other, find the Euler of this number. Euler of this number is 6. 3 raised to the power Euler of this number, mod 7 will be 1. If this is 1, then 3 to the power 102 mod 7 will also be equal to 1. Right, guys? Right? Simply multiple of 6. Okay. Then if this is 1, then what I want to take out? 3 to the power 104 mod 7. Till here it is 1. Fine. So what is remaining? 3 to the power 2 mod 7 is remaining, which is nothing but 9 mod 7, which is 2. Answer is 2. Is this clear now? Still, is there any doubt? Anyone? Still, is there any doubt? ये 102 कैसा है? Okay. See, 3 to the power 6 mod 7 is 1, right? So I will say 3 to the power 12 mod 7 is also 1. Because this 3 to the power 12 is what basically? 3 to the power 6 is square, right? That's it. So that is why if 3 to the power 6 mod 7 is 1, 3 to the power 12 mod 7 is also 1. Because 3 to the power, I can break this as 3 to the power 6 mod 7, which is 1, 1 cos square, which is 1. Okay. Hence, what is the nearest multiple of 104? Nearest multiple of 104 is 102. Okay, so this is clear. Then let's solve some questions. First question, solve it. No, you cannot. See, don't make one mistake that if you are say you are taking in these type of questions, you are finding the last digit. Suppose, okay, I have taught you how to find the last digit. Okay, this we have seen in the last lecture, how to take out the last digit. But what if the remainder is, see, this is 7, so remainder will be between 1 and 7. That is obvious. That is obvious in this case. But what if this number is, let's say, 210? Then the remainder can be a 2-digit number or a 3-digit number. Let's say the remainder is 149, let's say. And if you will find the last digit, you will always get as 9. Only you will get as 9. That is why we will find remainders as a whole and not last digit. Okay, so this question is 148 Are these two numbers co-prime? This 148 and 13? Yes, they are co-prime. So I can apply my Euler's concept. What is the Euler's concept? If these two are co-prime, and if this is a prime number, Euler will be directly 12, right? So 148 to the power 12 mod 13 will be equal to 1 according to Euler's theorem. Now, if this is 1, then 148 to the power 36 mod 13 is also 1. So what is remaining? 148 mod 13. What is the answer? Answer is 5. Anyone who is having any doubt as of now? Wait, Mukul, wait. We will solve questions. Don't worry. We will solve questions. First of all, is this clear, everyone? These two numbers have to be co-prime. Then only you can apply this Euler's concept. What if they are not co-prime? Then how to do? We'll see. Okay. Pavani, to do that, see, the 13 is a prime number, right, Pavani? So if these two are not co-prime, this has to be a multiple of 13, right? You can simply see that this is not a multiple of 13. And here also divisibility helps. The divisibility rules that we have seen, that will only help you to determine. We will see in the next further coming questions. Like, for example, this question. Also, I have told you how to identify prime numbers. This we saw in the very first class, right? That how to identify prime numbers. What were the two rules? Yes, 6k plus minus 1 and root. Yeah, root 1 was it. But distal, what was the distal sum? Distal sum can't be 3, 6 or 9. Okay. Yes. Good. But it was an elimination method, not a selection method. Okay. Now solve this question. Ishan says 45. So I'm having hell lot of answers now. What's the big deal? See, first step. Is 139 and 47 a co-prime number? Are they co-prime or relatively prime? Yes, they are relatively prime, right? Because this is a prime number. Okay. So these two are co-prime. If these two are co-prime, I can write 139 to the power 46 because this is Euler of 47. Mod 47 equal to 1. Okay. What is remaining? 139 to the power cube mod 47 is remaining, right? Yes, now you're getting the right answer. Why such calculation mistakes, everyone? And everyone is making that mistake. One has answered 4, 4, 4, 4, 4. Everyone answered 4. Anyways, fine. This is 139 mod 47. So what will be 130? First, how to solve it? What will be 1 after this step? After this step, Bharat, what? Okay. Okay, you wrote it, but what about others? Fine. After this step, Bharat, what we will do? Okay. Bharat, what is 47 into 3? That you can calculate fast, right? Yeah. What is basically what we are doing is that we have to come as 141, Bharat. We have to come as near to this number as possible, right? We have to come as near to this number as possible. So it is 141. Hence, 139 mod 47 will be what? Minus 2. Answer will be minus 2 cube, right? Minus 2 cube mod 47. What is 2 cube? 8. Answer will be minus 8. Clear? Minus 8 or 39. This will be your answer. This is how you can make it fast calculation. Just see what is the nearest multiple. Cool. Everyone. Next question. Solve this. Okay. Fine. Manali, tell me. I am dividing 10 by 3. What is the remainder? 1. Is 1 the only remainder? I am dividing 10 by 3. 1 is the remainder. Fine. But is 1 the only remainder, Manali? No. Right. Exactly. That's the point. The remainder is 4 also. If I'm taking it 2 times. This I explained in the first class, I guess. Remainder is 7 also. Similarly, remainder is minus 2 also if I'm taking it 4 times. Okay. So whether I'm in the previous question, if I'm saying that the remainder is minus 8, I can also say that the remainder is 47 minus 8, which is 39. Now is it clear? So this question, yeah, this mod 11, is this a multiple of 11? Plus, minus, plus? No, it is not a multiple of 11. Are these two co-prime? Yes. Can we apply Euler? Yes. So is this a prime number? Yes. What is the Euler? 10 will be the Euler. So 233 to the power 10 mod 11 will be what? 1. What is this? 440. How much closest can I get? This is 441. Priyam, which region, Priyam? And still you are attending class. Get dedication. I hope it is not that severe. Then be alert, and if required, then yeah, exactly. If required, 2.5 magnitude is not that much. It won't be a problem. So don't worry about it. But still take precaution, and in case it is needed, then go outside. That's what I would suggest. This session you can watch afterwards also. And take care, everyone who is in that region. So yeah, what I was saying is 230 to the power 10 mod 11 will be nothing but equal to 1. So how much close can I get? 440. I can get till 440. What is remaining? 233 mod 11. How to calculate it? We know the divisibility of 11, plus minus plus. Remaining is 2. Hence your remainder will be 2. Okay.